This is question 3 of the multivariable tips and tricks chapter of the regression models book. It says refer to question 1, add dummy variable law, and interpret the results. So in this question, we were working on the seatbelts data set, and now we have, if you go back to watch some of the earlier videos, which include some from the last chapter, we have created a normalized petrol price variable because we like the scale a little bit better, and we've created a 1,000-kilometer unit kilometers variable, and we've centered that. Both of these variables are centered so that we have a more interpretable intercept. The previous question asked us to do everything on the log scale, though this one is referring to question 1, so we're going to do it on the natural scale, unlogged number of drivers killed. And then all it asks is to, first we create this data set, and then we want to fit outcome as drivers killed, our normalized petrol price, our centered 1,000-kilometer unit kilometers variable, and the law variable, which is a 0, 1 variable. Now if I type summary of fit, there we see our coefficient table. The law variable is a 0, 1 variable. So this changes the intercept a little bit, in the sense that our intercept, 124, is our expected number of drivers killed for the average petrol price, the average number of kilometers driven, and before the law was in effect. Okay, so at the law at level 0. If we wanted to know what the intercept was after the law had taken into effect at the average petrol price and at the average number of kilometers driven, we would have to add -11. To interpret the law variable, what we're saying is we see that about 12 fewer deaths occur after the law had taken into effect, when the law variable went from 0 to 1. So we expect 12 fewer deaths associated per month associated with the law, holding petrol price and kilometers driven constant. Both of these other variables, petrol price and kilometers driven, are interpreted as we've interpreted them in the previous problems, though now they are interpreted holding both the other variable, whichever one, petrol price or kilometers you're not talking about, and the law variable constant at either 0 or 1. I'd also like to show you how we get the same estimates if we fit law as a factor variable rather than as a dummy variable, since all that R does is creates the dummy variables for you. Now I've fit the model, but I've converted the law variable to a factor variable. So R doesn't know that it's numerically 0 or 1, it just has two factors, one factor labeled 0 and one factor labeled 1. So if I do summary fit and just grab the coefficient table because that's what we're talking about, notice it is the same fit. Okay, notice that we get the same numbers, 124 for the intercept, -6 for the first one, -1.2 for the next one, and -11.9 for the other. R conveniently tells you which factor it's treating as the reference level or not for this variable. In this case, it's treating 0 as the reference level, and this -12 or -11.889, this is associated with the factor level 1. Okay, so that's what this little notation after the variable name is in R's factor output, is it's telling you which level that this coefficient refers to. So in this case, the -11 is demonstrating the comparison between when the factor is level 1 versus when the factor is at the reference level, which in this case, because there's only two levels of the factor, the reference level we know to be 0.